everybody, and welcome to this episode of the MongoDB podcast. On today's episode, we're talking with Daniel Norman from Prisma. Daniel is a developer advocate at Prisma, and Prisma is a next-generation Node.js ORM that introduces type safety, supports MongoDB in preview, and on this episode, we learn all about Prisma, all about Daniel, and all about ORMs, so stay tuned. If you like this episode, make sure you subscribe. If you're watching on YouTube, hit the thumbs up and subscribe so you get all our notifications of new episodes. Thanks, everybody. Enjoy this episode. Well, Daniel, welcome to the show. It's great to have you on the podcast. How are you doing today?
Very well. It's great to be here, Michael.
Fantastic. And where are you calling in from?
So I'm joining from Berlin, Germany, where Prisma originally started. Now we're a remote team, so we have developers all over the world, but I'm joining from Berlin, Germany.
Fantastic. Well, let's give the audience a little bit more background. Tell the folks who you are and what you do.
Sure. Yeah, so my name is Daniel, and I've been a software engineer for about 11 years. And throughout that time, I noticed a pattern in the different jobs and different projects that I worked on. And that is that in almost every role as a software engineer, you essentially need to store data. And typically that's done with databases. And so throughout my time as a developer, I worked with Postgres, MySQL, MongoDB, all of these different databases. And I've sort of noticed that it's quite challenging at times. But throughout my career, I did different I worked with different stacks, different programming languages, and the one thing that sort of seemed to stay more or less the same was the sort of database space. Of course, databases have evolved, and we've seen MongoDB really gain a lot of traction. I think it was one of the databases that, for me, really made it much easier to use a database, especially when compared to relational databases. I've been working in open source for a while. Prisma is an open source ORM, and just enjoying really working throughout the technology stacks. I've done some front end, some back end, and infrastructure work throughout my time. Yeah,
Fantastic. Well, it's great to have you on the show. I'm excited to talk about this space because, obviously, let's get into the concept of an ORM. Tell the folks what an ORM is and why they might be interested.
Yeah, so an ORM is an abbreviation for an object relational mapper. And really, the main responsibility of an ORM is to make it possible for you to bridge the gap between the two different paradigms that programming languages, especially object-oriented programming languages, and the way that data is stored in typically relational databases. And because these two paradigms are different, that is object-oriented programming and this whole idea of objects, and relational databases, the way that they store information is using a different paradigm. It's not quite intuitive how the mapping should happen, especially when you store all of your information in the database, but really you're interacting with it, you're implementing all of your business logic in an application. And so generally the space of the superset of ORMs is what is called the database access libraries. And these include, low-level abstractions such as a database driver. In the case of relational databases, you would just send raw SQL queries and you would get back data. And then in the case of, say, MongoDB, you essentially get back objects. And so ORMs really make it possible for you to use objects to interact with databases and to use these objects that adhere to the same structure as your programming language. Now, I should at this point say that not all ORMs are equal. There's, generally speaking, two sort of main flavors of ORMs, and those are active record ORMs, and the second is data mapper ORMs. And active record ORMs might be very known to Ruby developers who've worked with Ruby on Rails. The name of the ORM that is built into Ruby on Rails is called Active Record, but Active Record also refers to the sort of the approach. And the general idea there is that you have these rich object instances. They're called model instances that store also the both the information that has been fetched from the database, but they are also rich and they contain all of the methods that you need in order to persist changes. So here's a concrete example. In an active record ORM, you fetch a user record or a user row from your database. You make a change, say, to the last name field, and then you hit on the same object the .save button. And that will actually then send a query to the database. And from your perspective as the developer, really all you're doing is just interacting with this one object that provides all of the functionality. And of course, under the hood, these operations are converted into SQL queries, which are then sent to the database. So that is active record. And then there are data mapper ORMs. And in data mapper ORMs, you essentially introduce this sort of intermittent layer that converts the sort of or transforms the structure that is coming from the database into an object in your programming language, and that typically adheres to or is a children type or a children class, a child class of the structure that you've defined, the model structure. And that sort of the data mapper pattern gives you a bit more decoupling between the database layer and sort of how you interact with objects inside your application. And at this point, it's maybe worth introducing Prisma, because Prisma, in many ways, we call it a next generation ORM, and that is because we sort of really studied a lot of the challenges. There's a very common problem known with ORMs that is known as the object relational impedance. The object relational impedance mismatch, and that refers to this.
Yeah. I want to make sure we dig into the impedance mismatch. Go ahead and explain that.
Yeah. So this is a general term used to describe the challenge of sort of dealing with these two representations that don't really sort of match one to one. And there's a famous essay called The Vietnam of Computer Science, which really refers to how many of the ORMs in this space have really failed to bring sort of the promise. And ORMs are a very controversial topic, and probably rightly so, because it's such a critical piece. I mean, if you're working with any kind of data, then you really care about how your developers or how developers in general sort of interact with that database and really make assumptions that are correct. And when you have a lot of these challenges like the object impedance mismatch, that really just describes the sort of mismatch between the representations and sort of like there no being clear guidance on how you should represent things in your programming language. So these are challenges that have sort of been accepted, and there's different opinions about how they should be dealt with. Some say, well, you should use the data mapper pattern. Some say, well, the active record is better. Some say, well, you know what, all ORMs, that will take you 80% of the way there, and for the 20% of the cases where you need raw SQL to do some advanced stuff, great, you should have an escape hatch and you should be able to do that. And in that sense, you really get a lot of sort of benefits from using the ORM, because you don't just repeat yourself constantly writing the same queries. That's sort of been the state of like the landscape for a while. And there's been many different ideas in the sort of developer communities about how we can improve them. And I think one of them that is really gaining traction is this idea of type safety. And if we look at, say, the JavaScript ecosystem, we've really seen what happened since the introduction of TypeScript. I believe it was around 2015 or 16 when TypeScript came around. And really, it followed a very simple proposition. It was the same JavaScript code you write, you annotate it with some types, and then we'll ensure that you make less mistakes in your code. And at first, there was a bit of pushback, but I think what we're seeing now as sort of time has passed and the ecosystem has matured, and both the TypeScript compiler itself has matured, is we've seen that if we can offer through libraries, I mean, the Node.js ecosystem and JavaScript even broadly is really known for its rich ecosystem of libraries and so on. And so many developers, when they're building Node.js applications, really they are not always writing everything themselves. They're relying on a lot of libraries. And so I think one of the big sort of breakthroughs in terms of TypeScript adoption and adoption of the idea of type safety was the adoption of TypeScript by libraries, because suddenly if you're a library user, and whatever library it is, suddenly your experience using that library is much better. You get these rich auto completion, you get the squiggly lines, and what you see is that you tighten really this feedback loop that and by feedback loop I mean, say you write code, and there's many different situations where you're writing an SQL query or you're writing a database operation, and you can't verify that to be correct until you actually run it. And so then you start relying on unit tests, or you start relying on runtime functionality in order to ensure the correctness of whatever it is that you're building. And what TypeScript offers is it offers a tighter feedback loop. So as you're writing your code, assuming that the code is typed, if you're using a library, if you pass an argument that is an integer, or a number I should say, in TypeScript, and the function expects a string, then you will get a squiggly line and you will get that error very quickly as you're writing the code.
And that's built into the library.
Yes. So in general, libraries now will include these typings inside. In fact, many libraries are now written from the get-go using TypeScript. So it's not even an additional step for the library author, because he's written the whole library in TypeScript. But really, all of these benefits can also be had even if you're just using JavaScript and you're importing a TypeScript project, as long as you're using VS Code, because VS Code has the sort of the TypeScript language server sort of running in the background and type checking your code. And so really I should at this point say that all valid JavaScript code is valid TypeScript code, which is why you can get all of these benefits.
It's a superset.
Yeah. And again, this is just the broad sort of evolution of the idea of type safety and TypeScript in the JavaScript and Node.js ecosystem.
Yeah. So I want to pause for a moment on the TypeScript, and I love the progression so far. We've talked about, at a high level, what Prisma is, what ORMs are. We didn't really touch on what the difference between an ORM and an ODM is, but I like the depth that we've touched on the ORM space. But I have to ask the question, MongoDB is essentially JSON, well, it's BSON typing, and as it's represented in JavaScript code, it's objects. And you natively interact with the database using objects. Why would I need an ORM or an ODM if I'm using an object-oriented or a document-based database like MongoDB?
That's a great question. Maybe we can first tackle the ORM versus ODM. I think you've done most of it. But really, so we had these ORMs. These were libraries that essentially just made it easier for you as a developer to interact with your database. In many cases, you didn't need to know raw SQL. But then comes MongoDB along, and it's like, well, you can persist your objects pretty much as they are in the database. Why do you suddenly need to introduce something like a library or an abstraction on top of that? And there's a bunch of different reasons. I think the main one to start with, and it would be probably good to sort of take Mongoose as an example, because Mongoose is a very popular ODM, object document mapper, for Node.js. And I think the main value proposition that Mongoose offers is this idea of a schema. And this touches on another important feature in MongoDB, and that is that MongoDB doesn't enforce a strict schema by default. And so you have this flexible schema, and this is great because as a developer, you just start pumping your data into the database, into MongoDB, and you're all happy. It's stored and it's all great. But then suddenly your project becomes popular, and suddenly you have feature requests, and suddenly you want to invest more time in implementing those feature requests. So you start going ahead and you're like, oh, well, I need to store now. I want to provide authentication through Facebook and through Google. So you start adding all of these functionality, and suddenly you need to store that new information somewhere. So suddenly your new user objects or documents, I should say, in the case of MongoDB, they contain more information. And what you end up having is you end up having a collection of documents that do not match, do not have the same shape, do not fit into the same schema. And this can really be a challenge because suddenly it becomes an application level responsibility to manage all of these differences between documents within a single collection. So you have a collection of users, and each user looks perhaps slightly different depending on when it was created. And so that sort of lays out the general problem of having inconsistencies within a single collection. It's by definition not necessarily a bad thing, because it allows you this rapid prototyping, but suddenly it becomes this new responsibility that you have to manage. And there's many different ways to sort of manage that. But I think, if I remember correctly, MongoDB introduced this idea of JSON schema validation. Yeah. Was it in version 3.0?
3.6 maybe? Yeah.
So at some point, the MongoDB team, right, you decided, hey, like this could be valuable to some of our users. And I'm sure that many of those users had been using MongoDB for a while, and suddenly they realized, well, we want to put some more guardrails in place. And Mongoose had already been around, and it introduced this idea of a schema. And really, the word schema comes from the Greek word schema, which means shape, which coming back to this idea of types and type safety, really, a type is really just describing the shape of information. I mean, sure, there's a whole academic area of research and type theory and set theory and whatnot. And of course, it's a bit more complex than that. But on an abstract level, really, I think that types and schemas really have a lot in common. And the reason that I mentioned this was because one of the ways of dealing with these challenges of inconsistencies in your collection in MongoDB was to introduce a schema to put more guardrails in place to really constrain your own work as a developer to avoid making mistakes. And Mongoose introduced that by introducing a schema on the application layer, which means that Mongoose itself is the one that sort of verifies that you're adhering to that schema. MongoDB's schema validation using JSON schema was also a very welcome addition, and it allowed us now to sort of push that responsibility to the database layer. And these are all great solutions. However, there's one challenge with them, and that is, when do you get that feedback about you not adhering to that schema? So, for example, you have a user collection and you've defined the schema for it. In Mongoose, that would be, say, using your Mongoose model object, I believe it's called, where you sort of define the schema for a user. And then you say, okay, I want to have a first name, an email, and say a password hash. And then suddenly you go ahead and you decide, I want to start persisting also a last name or a surname, as I'm used to saying. And you have to actually run that query in order to get that validation error. So you actually, again, it's a runtime check that happens when you actually submit that request.
In the database, yeah.
Well, in the case of Mongoose, it's Mongoose in the application layer. If it's JSON schema using
right.
MongoDB, then it happens, of course, when you submit the query to MongoDB, and then it's like, well, no, you have the schema in place, invalid, and you get the validation error back. Prisma sort of took this idea of like introducing a schema and was like, can we enforce this the earliest possible point of time? And that is as you're actually writing the query. And as I mentioned before, you know, in the case of libraries with arguments, really, as you're writing the query, you get the squiggly lines as you try to persist a last name field into your MongoDB database. And so I think really the sort of the TLDR version of this very long-winded answer is you get a tighter feedback loop when it comes to enforcing the schema validation.
Yeah, fantastic. So, yeah, I love it. And, you know, the stated mission of developer advocacy at MongoDB is to improve the lives of developers and make it easier for what they do. And I think that falls right in line with it. So I love what you talked about at developer time, not at runtime, not at test time, but at developer time. And it actually has me thinking about tools like Copilot. I'm wondering if it can even back it up even further. Now that you've got type safety, you've got your schema in place with your ORM. I'm wondering if that's going to simplify the process of suggesting code that you may be trying to write. Have you explored Copilot at all?
Yes, I have. In fact, as a developer advocate at Prisma, I do also a lot of writing, not just code, but also, you know, the English language, I should say. And it's just been fascinating to see it almost finish my sentences as I'm writing Markdown, even in just English. But yeah, sort of broadening this, or rather focusing this on the idea of like programming as you're writing your queries, like can something like Copilot help you? Absolutely. But I think one of the things that, most of the users who try out Prisma, what they notice is that they get this rich auto-completion.
Mm-hmm.
And so with this rich auto-completion, really, I think it takes you already 90% of the way there as you're writing the query, because you have the underlying type. As you're writing the query, you essentially do control space in VS Code, and it shows you the suggestions. And those suggestions that you get are just the fields that are defined in your schema.
Yeah.
And so I'm not sure how much more that can be improved, from the perspective of a developer. But I think that GitHub Copilot in general is a great it's a great sort of leap for the whole ecosystem, and
Yeah.
it'll be curious to see where that what kind of developer tools we can build using that technology. I think it's
For
still
sure.
very early.
Yeah, definitely. So I want to get back to Prisma, and I'm thinking about Prisma as a cross-platform tool. Maybe talk a little bit about the use cases, or the development environment where Prisma might be especially attractive in that space.
Yeah. Michael, would it be okay if I introduce? I spoke a lot about type safety, but I think there's two more important
Oh yeah,
concepts that
absolutely.
I'd love to cover, and I think that will sort of set the foundation for like, okay, how can this be useful in different scenarios?
Yeah, sounds good.
So we spoke about type safety, and really as a way to ensure that the application code that you're writing, interacting with the database, can only do so safely. So if you don't have in your schema, in your database schema, a last name or a surname field, then you should get an error for that as soon as possible during development time. And so that was this idea of type safety. But type safety typically requires you to define these types up front. And as I mentioned, if you're using libraries that have been built in TypeScript or that have TypeScript typings built in, then you get that sort of at zero cost. But given that you want to get this type safety now for your database schema, that's not something that a library can know for you. So this leads us to the second important concept in Prisma, and that is cogeneration. And the idea of cogeneration is really based around this idea that you should only need to write things once. So for example, if you're working with relational databases, typically you have to define your database schema in SQL, and then you also have to define your models, and they have to match one-to-one, and then it's still your responsibility to do that mapping. Of course, with MongoDB, you don't have this strict schema.
By default.
By default, right? But you can sort of introduce that. And so cogeneration in Prisma is built around this idea, okay, you should only write things once. And that leads us to the third concept, which is the Prisma schema. So the Prisma schema is a single source of truth for both your database schema and your application models. And coming back to cogeneration, there are two main things that are generated from your Prisma schema. The first one is the type-safe database client, which is sort of tailored based on the schema that you've defined. And the second thing is migration files. And right now, the MongoDB connector for Prisma is in preview mode, and we're still working on sort of improving, because we don't have this concept of SQL migrations in Mongo. But still, whenever you change your schema, you probably want to carry out data migrations. Like if you introduce a last name field and you had just a name field up until that point, you might want to go through each of the documents, split the name into two fields, and then move the last name into the new field, into the new field. So that would be.
So let me just clarify. Are you saying that Prisma's ORM will, on a migration, go back through the database and adjust the schema? If a document I had written previously yesterday, before introducing a change to the schema, did not have last name, it only had name, and I adjust the schema in Prisma to include a first name, last name, I perform a migration. Now, when I go back to my database, will I see a blank first name and last name?
Great question. Yes. So right now we haven't implemented all of this functionality. So a lot of what I'm describing when it comes to data migrations is really like the last mile for us in terms of really like making the MongoDB support production ready.
Mm-hmm.
And the big thing is really introspection, this idea of like scanning through your documents and being able to tell you, hey, you have these discrepancies. That's one aspect. And the second aspect is it's natural for you if you're doing rapid development, if you're building an iterative product that is continuously evolving to change your schema. And so providing the tooling, they're using Prisma Migrate, which has already been sort of production ready for almost a year now for relational databases. So then taking a lot of the ideas from there and applying them to MongoDB. But the idea there is that you introduce a new field and then you can define a data migration that will allow you to control how you migrate those old documents that didn't have the first name and the last name into the new structure. And so that's sort of what I mean with migrations. So by having this Prisma schema, the single source of truth in your GitHub repository, typically that's where it would be stored, then you have the full history of your schema. And then based on that, you can also make all sorts of decisions about how you want to migrate the data to ensure that all of your documents are consistent. And this is really what we're working on now, because some of the concepts in MongoDB don't map one-to-one with relational databases. And really, we've learned a lot from building Prisma Migrate initially for relational databases, and now we're sort of applying those concepts to data migrations in MongoDB. So just to sum it up, cogeneration, the Prisma schema, the single source of truth, we generate the fully type-safe database client for you based on the Prisma schema, and also will help you to create the data migrations based on the changes that you carry out in your schema. And then finally, type safety, which means that you get that tight feedback loop as you're writing the code. And I guess that sort of brings us back to the original question you asked. Okay, so in which environments is this useful? Who can benefit from this? But I'll pause there in case that was too long.
I just wanted to ask one more question about active record that you talked about earlier on in the episode. And I understand the concept of storing your methods with your object definitions. Does Prisma will support that, correct?
No. So Prisma is, in a sense, it's a next generation ORM. So what you get is you get this generated library that you import into your application. You instantiate it to initiate the connection with the database. And essentially you have there like namespaces for each model or each collection. A model in the Prisma schema maps onto a collection or a table in relational database. And then for each one of those, you have a set of methods that you can use in order to query the database. All of these methods are scoped within the Prisma library that you import that has been generated for you. And it will always just return plain old JavaScript objects that are fully typed. So if you choose to also fetch references, embedded docs, all of these will be fully typed for you. And the benefit of that is that you don't necessarily need a lot of this active record functionality, because essentially, if you want to make a change, well, you get that returned object, you can make changes to it. As long as it still adheres to the type, you won't get a type error. And then you can use that data that you've changed in order to persist that in a separate query. But the sort of the contract there when it comes to Prisma Client is that it always returns plain old JavaScript objects that are fully typed.
So the use case I was thinking about around the methods, I mean, I typically with Mongoose, for example, will create a get and a save pre and post, and do some formatting. For example, with money, with a money field, a currency field, I'll ensure that it's the right number of digits or multiply. How would I accomplish that with Prisma?
One thing I had a question for: what did you mean by pre and post?
Pre-save and post-save. You have hooks in the Mongoose library to create functions that are fired, that are triggered on right before you write to the database, right after you write to the database, and right before you read.
And in this example that you gave, what were you doing prior to the query, and what were you doing after the query?
So I'm working on an e-commerce application at the moment, and I'm prompting the user for a value that will be stored in the database. Actually, for the GitHub Student Developer Program, we issue credits, and the credits are in some value. And on the administrative interface, I prompt the administrator to put in the value of the credit code. and the credit code can be put in as 50, like a whole number. I want to store that in the database as currency, so I want to multiply it by 100 and store it as 5,000 with an implicit decimal point. So I do that in a pre-write, pre-save.
Yes. So how would you achieve this with Prisma? Well, essentially, you have to know what your input type is, and you're getting that essentially from user input.
Mhm.
And you might want to run some validation on it to make sure that it's only digits. This is something that cannot be done on the type level because it's user input that you can only know about during runtime. And so once it passed the validation, then you sort of still have the full flexibility to transform it in any way you need before persisting it in the database. Typically, we also support the decimal type in Prisma, and I need to look up how that maps onto the MongoDB types, but really, I believe that it's just represented because
probably floating or integer.
Or a string, really,
or a string.
I think it could very well be a string that it's represented as, and so that's generally how you would approach a similar thing. Now, I should say we also have this thing called middleware. We also have hooks where you can sort of hooks into different parts. Middleware essentially allows you to tap into the process of query execution. So you can have a central place where you sort of define a hook, and you might use that for instrumenting your application, like tracking counts of the queries. So you can do a lot of different things with middleware, similar to what you would do with hooks. And we also have this idea of like events that you can sort of listen to that are very similar to hooks.
Okay, great. Well, it sounds flexible, and I like that. Love the flexibility. So let's continue, and let's talk a little bit about the use cases where Prisma might be especially helpful.
Yeah, I think it starts from an individual developer. And I can say this just based on my own experiences of working at different companies, and suddenly there's an idea for a new project, and they decide, okay, the team will form a team that will focus on bringing this project to fruition. And in such situations, then you would typically, start out with some kind of an MVP. And during the MVP stage, really, you want to make something that works quickly and something that could be potentially built upon, that isn't necessarily just a demo that can be thrown away. And I think in such situations, because you just get this a lot more confidence just knowing that you're making the correct queries as you're writing them, in addition to giving you this like healthy guardrails of like, you have to define the schema up front. That's always the case, unless you're sort of introducing Prisma into an existing project. So really, I think when you're starting a new project, there's a lot of benefits. You get this sort of productivity boost through the generated code and all of the generated types that give you this rich auto completion. It's much easier, for example, with Prisma to do what we call nested writes. For example, there's generally two data modeling approaches with MongoDB. You can use embedding and you can use references. And I guess references are reserved for situations where you might not care so much about the performance, but you might care more about keeping information normalized and sort of consistent in a different way. And what you can do with Prisma is really using a single query. You can do operations that work on multiple collections. So for example, if you have a reference between, say, a user and posts, assuming that you go for the normalization approach where you have two collections and a reference between them, you can create a user and multiple posts all in a single query. And you get the type safety there. You also get the confidence that you don't necessarily need to write all of the tests to test out all of the different possible scenarios in order to know that the queries are valid. So that already gives you sort of this big boost. And that's like on the individual level. I think where it gets really interesting is what you see happening the moment that it's adopted within teams. And typically development teams today, I mean, they're structured in many different ways, but I think it's still very common to sort of have dedicated teams working on multiple clients, especially in companies where you might have a single API, GraphQL, REST, whatever it is. And you might have multiple teams working, say, on an Android app, an iOS app, and a web app. And of course, there's some horizontal concerns where they might meet together. But if we sort of think about these environments that are very common in e-commerce, in a lot of different industries, what you see is that essentially the API becomes something like a contract between backend developers and the front-end developers who are building the different clients. And I think in such situations, we've seen just what happened to the ecosystem as a result of something like GraphQL when compared to REST. At the time, REST was a very loosely defined specification. And when GraphQL came around and sort of imposed this idea of a schema, I think that a lot of people sort of like realized, wow, this is like, at the time, I know that contract testing was a big thing. I think it was being done at SoundCloud. And it was like, that was sort of the state of the art of like doing these tests between clients and between consumers and producers, and like, clients and APIs in such environments where you have multiple clients consuming from the same API. And I think that GraphQL eliminated a lot of the challenges inherent to the approaches prior with REST. I mean, now you have this open API spec that you can generate, and there's a lot of tooling. But if you look at just GraphQL, you have a single schema, and from that schema you define, your resolvers, and you can provide a lot of rich functionality. And I think that was sort of a testament to the power of schemas. And sort of coming back to this idea of the Prisma schema as a single source of truth, I think that in a team collaborating on a project, both multifunctional doing full stack, or a single team sort of building an API and that being consumed by different users, you get a lot of these benefits from just having this one file that is like the contract that everyone sort of agrees on. And sort of everything is derived from that. If that's the GraphQL sort of layer that is built on top of the database schema, that's one thing where you have at least this sort of base contract. And so I think that's one benefit that you get in teams. The second is this idea of type safety. It's a lot easier now to sort of do code reviews, because if someone was writing raw SQL and he didn't write tests for the new functionality that he added that makes use of raw SQL queries, then suddenly it's up to you to write those tests or to test out the queries and to sort of like manually go through a lot of that. If you have a way to verify that at build time, and really this should be possible. It's I think that it is possible to verify, either using Prisma, but also I think that we're seeing now a whole the ecosystem growing and people understanding, you should be able to also type check raw SQL queries, or whatever it is, operation that you're doing against another system. If you can verify the correctness of that operation very early on, then suddenly you get a lot of these improvements in team collaboration, because suddenly reviewing someone else's work is not so it's not such a big burden. And this sort of like is a good leeway into what we're trying to achieve with the Prisma data platform. Really, we believe that a lot of the scenarios that we speak about in these kinds of conversations and interviews about software development, really they don't really take into account the sort of diversity and the complexity that you see in enterprise and just really in the industry in practice. And what you see in reality is that a lot of companies have a lot of legacy code bases. They have a lot of existing projects. They typically have multiple databases, and and one of the big challenges there is that each one of these databases might have its own authorization mechanism, and suddenly horizontal concerns like how do you streamline querying, or how do you fetch data from someone else's database in a different team, right? Like say you have a bigger company where sort of you have microservices, and you have one team that is responsible for fulfillment, and one team responsible for payments, and the other for the shopping cart in kind of like an e-commerce business. Suddenly you have 3 different data stores that all hold critical information for something that you want to do within the company. Or the fulfillment team wants to know how long it takes from the moment that a user makes an order until the moment that the delivery gets sent out. And in order to sort of even introduce this idea of an order, they have to pull data from a different database that they don't own as a team. And of course, there's compliance and all sorts of challenges that arise in such situations. And so the vision of sort of the Prisma data platform. So Prisma today supports MySQL, Postgres, SQL Server, Azure SQL, and MongoDB, which is currently in preview. We're hopefully going to bring that to general availability by the end of this year. And then the idea is, okay, you still have this unified querying interface that works with all of these different databases, and you now have a schema, that is consistent, or at least the same kind of schema that can be used to represent all of these different databases. And you have code generation, so you get this zero cost type safety in your clients. And so it's like, okay, so how can we make it possible now for a developer in team A to pull data from team B? And this is where the Prisma data platform comes in. And the Prisma data platform really is an idea that is heavily inspired by the technologies, the custom data access layer that has been used in companies like Facebook and Twitter. At Facebook, they developed a technology called Tau, which essentially allows them to both scale their databases, but also give any developer who's starting out access to all the data that he needs without sort of having to now connect directly to this database or that database. At Twitter, they built something slightly different, but sort of, again, the same idea in mind, called Strato, which was, again, to sort of build this data access layer that allows you to fetch data from different teams. And when you sort of have this, so this is basically the vision to really simplify those processes and allow you, essentially, if you're starting out a new project with Prisma, to go from a single developer all the way to, say, 150 or 200 employees, and sort of provide you with the tooling to grow that. And that is essentially a cloud product. It's already live and it can be used today. I mean, one of the ways that you can try out Prisma today is, of course, it's open source. So you can install it locally and try it out. And of course, you can also try it using the Prisma data platform, and essentially allows you there to create a GitHub project and to provision a database, and you have a data browser, something like, I believe it's called MongoDB, not Atlas, Compass. Is it Compass, right? So that's what Prisma Studio is, and we have a hosted version of that in the Prisma data platform. And you can already sort of play around and get a feel for different queries and what they look like. And so this is currently sort of like the baseline for our broader vision of this Prisma data platform. But I'll pause there because that was a lot.
No, it's so exciting. I'd love to hear more about the data platform. What's happening under the covers? Where is this data actually residing?
Yeah, so again, the data resides in the database where it's always been. The Prisma data platform, of course, if you're starting a new project, can help you if you want to provision a database. And so right now we support Heroku, and we're also working on adding PlanetScale, which is a highly scalable version of MySQL. And of course, in the near future, we'll also be looking to integrate with MongoDB Atlas so that you can really have a choice. But this is if you're starting a new project. If you have an existing project, really the idea is for you to be able to connect all of those databases through the cloud platform. And then essentially we run this sort of infrastructure component for you that serves as we call it the data proxy. And in the first stage, we're now about to launch the early access version of that. It'll do a lot of the connection management when it comes to serverless deployment. So in the last couple of years, really, the serverless paradigm has really taken the development community and the infrastructure world really quite far ahead. But there are still many challenges when it comes to connection management, because essentially a lot of these serverless functions, they each one of them serves only a single user request. And essentially what you have is you have the situation where you have loads of these instances opening up a connection to the database and then closing it, and then opening and closing it. And databases typically weren't really built to sort of handle that level of connection churn, especially because typically you had multiplexed apps where you have a single Node.js instance serving 100 user requests at the same time using the event loop. and then sort of funneling the queries, if you have database queries for each one of those user requests, onto the database. But that Node.js server sort of maintains that open connection to the database. And so as requests in, it just funnels them through. With serverless, you have these new instances that are starting up and they're only serving a single user request, and they have to open up a connection and close it. And for a lot of databases, they have to sort of allocate memory, and every time a new connection opens up, and of course you have today, everything is using TLS. And so you have TLS termination, and that adds a little bit of overhead. And so a lot of developers who sort of been attracted to serverless because of the allure of like, infinite scalability, you don't have to worry about running servers, have really been a bit burnt, I think, by some of the rough edges that are still present. And so the first step really is for us to solve this connection pooling problem. That is just a pain if you're using serverless environments. And we do that essentially. I should mention this is an important technical detail when it comes to Prisma, but Prisma uses an engine, what we call the Prisma engine or the query engine, that is written in Rust and is highly optimized, and that handles all of the heavy lifting. And so that typically runs as a sidecar process inside your application. And by sort of moving to the cloud or the Prisma data platform, what we can do is now we can essentially run this for you in the cloud. That maintains the connection pool to your database. And then all of your queries, and so sort of coming from, say, serverless functions, first of all, the serverless functions are much lighter because they just sort of relay all of the work to the proxy, and that maintains an open connection pool to the database. So you get a lot of these sort of performance optimizations out of the box, in addition to all of the added functionality, like being able to have collaborators through this query browser. You can sort of explore queries, you can explore the data, and that sort of provides the foundation now for all of the collaboration workflows around this, working with multiple environments, querying across multiple different data sources. Of course, this is part of the grander vision, but like, it always sort of has this like a couple of steps, and suddenly it's like, oh, wow, now we get this. And so my feeling is that solving the serverless problem is like the foundation for doing a lot of this, because
I'm curious about, so now that you've got this proxy layer, is there caching? Are there optimizations associated with caching data on request, or?
Yeah, this is of course one of the like the main features that we can introduce once you have a proxy sitting in between that does connection, but it's like, okay, caching becomes trivial.
It's exciting.
It's definitely on the roadmap. Yeah.
Hey,
caching, I mean, audit logs. I mean, there's so many different, potential sort of use cases for this, depending on the kind of company and the kind of product that you're building.
Absolutely. So where can we see Prisma in the wild? Who's using it that we might recognize, if you can drop any names?
Yeah, sure. So you may have heard of Rafa. They produce some like higher-end cycling equipment. A company called Poppy. Gatsby is also using that internally. I have heard, I don't know, it wasn't sort of a formal thing, so I probably shouldn't mention that, but Poppy is building like a sort of a car sharing platform that is already in use, I believe, in the Netherlands and I think also in Belgium. And they're using Prisma for this. Twiga, which offers all sorts of like products, groceries and so on, like direct from suppliers. They're using Prisma. Did I mention Gatsby's using it internally? Grover, which basically resells leases different gadgets. They're using this, and Panther, which is also an automated global like payroll and compliance for remote teams, are also using Prisma under the hood. So really, we've been seeing over the last, so we released Prisma to general availability around May, June of 2020. And since then, we've really seen sort of the adoption grow quite steadily in that time. And I think we're going to see more and more products that are like, they a lot of products, when they're first developed, they're not always doing this out in the open, and they're not always sharing all of the information about their engineering stack. But
Yeah.
it'll be really interesting, I think, in the next couple of months to see how it's being used. I mean, just looking at some of the use cases now, they seem to be quite versatile.
Mm-hmm. Fantastic.
Yeah.
So we're just about out of time, but what I'd love to do is invite you to come back. Let's do a stream, and let's have you fire up a browser and show us what it looks like to interact with Prisma and kind of do a little demo. Does that sound good?
Yeah, absolutely. I'd love to do that. I think in the words of Linus Torvalds, talk is cheap. Show me the code. Yeah, we can talk all day, but really, I think it's best emphasized once you see it in practice.
Yeah. Okay. So we'll get that on the calendar for one of the next episodes that we put out. Daniel, this has been a great conversation. I've learned quite a bit, and I'm excited to jump in and try Prisma. Anything else you want to share with the audience before we wrap?
No, I just wanted to thank you really for asking all these great questions. It's been a really fun chat, and I hope that we can continue this discussion. And besides that if you want to try out Prisma, you can go to www.prisma.io. You can also try out the cloud product. If you're using serverless, I think you might gain a lot of benefit from the upcoming data proxy. And I'll leave it at that. I think the rest we can dive into in the next one.
Sounds good. Thanks once again.